So to make these biaryl compounds, we also need to talk about these organometallic reagents. Now we're going to start with a pretty narrow focus where we're just going to look at our aryl metals, and we're only going to talk about Grignard reagents. But remember, when we look at these metals, we can simplify and identify their activity by saying, oh yes, that's a benzene ring, and it has a lone pair, and it's an anion, and then a positive metal. So what is the positive metal? Well, for us, on this slide, it's going to be magnesium. How do we make a Grignard reagent? Well, we simply take an aryl halide, and we treat this with magnesium metal, metallic magnesium, that's magnesium 0 oxidation state, in an aprotic solvent like ether or very often THF. And we get the Grignard reagent. Okay, and when I typically think of Grignard reagents, I think of them as organometallic species or as ionic species. And in my head, I ionize that bond, and that helps you recognize, oh yeah, that carbon, it's got a negative charge, it's highly reactive, it's a strong nucleophile. Okay, great. Now let's look at this a little differently. I'm going to introduce some terminology. Let's do the bromide this time, just to give us a little bit of variety. And we'll react this with magnesium again. And this time, let's tell you what, let's do THF as our solvent, just to recognize it doesn't have to be ether. And again, we form the Grignard reagent. Nothing different here. Now, I want to take this structure, and now I want to make every bond in it, all these bonds, I want to make them, all of them, ionic. So here's our carbanion, just like we drew up above it. We're going to have magnesium. Now the magnesium is not going to be +1, it's going to be +2, because we're going to break off the Cl-. Now what I want to emphasize is the fact that we have magnesium +2. If you look back to the left, we started with magnesium 0. So what has happened to the magnesium? Magnesium has been oxidized. So actually, people talk about this, it's an oxidative, let's change that I, oops. People call this either an oxidative insertion or an addition. Now when they say it's oxidative, what they're referring to is what happened to the metal. The metal was oxidized. Specifically for us, it's magnesium. It went from magnesium 0 to magnesium +2. This is an oxidative addition or an oxidative insertion. We're actually going to see this language as we look at more of this chemistry, but this is a term we're going to see that metals will change their oxidation state. Therefore, we can think of these as oxidations and reduction reactions as well. Regardless, from this slide, the point is we know how to make organometallic reagents. You take a halide, treat it with magnesium, and you get a Grignard reagent.